So suppose its magnitude is say some 10 meter. Okay, so then what is the unit vector? Unit vector we have to denote it by a cap. So a cap will become vector A divided by magnitude of vector A. Vector A divided by magnitude of vector A. Okay, so if you take the vector and divide by its magnitude, you will get what? You will get the unit vector. So unit vector you can simply write in words as unit vector. Simply you can write in words as say what is that? Vector divided by magnitude of vector. Okay. So for this example, how you can write? You can write it as a cap is equals to vector A is what? Vector A is 10 meter in the some. I will take this as west direction. Okay. So if I take this as west direction, so 10 meter in towards west. So 10 meter towards west. So divided by, so what is its magnitude? Magnitude is 10 only. So magnitude is 10. So this 10 will go. So unit vector A cap will become 1 meter towards west. Okay, this is going to be what? This is going to be a unit vector. Now if you multiply its magnitude 10 to this unit vector, again you will get what? You will get 10 meter towards the west, means you will get the actual vector if you multiply with the magnitude. Okay, or sometimes they may denote it by the lowercase letters also. A cap equals to vector A divided by magnitude of vector A. Okay, so as you know, if you take the coordinates x, y, z. Okay, so x comma y comma z, x y z. Okay, so in case of x y z, this is what the origin. So you can take anything here, velocity, or it may be a distance, or it may be a displacement, it may be a time, whatever. Y also you can take any quantity. Okay, these are the what? Empty. So you can take anything along the x, y, z. Okay, so suppose if you along the x if you take some quantity, then what is its unit vector? So you have to take unit vector over here. If you multiply that unit vector with its magnitude, so you will get the actual length of the vector, or actual vector. So this unit vector along the x-axis we call it as the I cap. So unit vector along the y-axis we call it as j cap. So unit vector along the z-axis it is called as k cap. Okay. So remember, unit vector along x is I cap, unit vector along y is j cap, unit vector along z is k cap. So why I say k only? You can take element, you can take some x, y, z, some you can take p, q, or whatever, that depends. But in general, whenever you get the problems or something, they use it as the I cap, j cap, k cap. Okay. So suppose if I multiply I cap with 5 I cap, what it means? You are multiplying I with a 5, means you are adding I with I 5 times. So this is 1 unit, so this is 1 unit, this is 1 unit, this is 1 unit, so this is 1 unit. 1, 2, 3, 4, 5. So this is what your 5 I cap from here to here. I hope you are getting what exactly this unit vector means. Okay. So that is what the meaning of unit vector. When you multiply unit vector with some number, you will get the what actual vector. Okay. So this is what. So what are the in last class I have asked you what is the magnitude of I cap, magnitude of j cap, and magnitude of k cap. Okay. So as the name is suggesting, its name is what? Unit vector. Unit vector means the vector whose magnitude is equal to unity. So obviously I cap, j cap, k cap are the what? Unit vectors along x, y, z. Since I am saying they are unit vectors, magnitude is going to be 1 only. I hope most of you got the answer. So if you got so 1, if you thought if it is answer is 1, so obviously you are getting something. Okay. So this is what the all about unit vectors we have discussed in our last class. Suppose if the unit vector is multiplied by its magnitude, so what will happen? This A is a unit vector. So this is what magnitude. Okay, so what you will get? You will get the real vector. You will get the real vector. Okay, so when unit vector is multiplied, when unit vector is multiplied by magnitude of the vector, then it will give, then it gives what is that? Actual vector. Okay, so if actual vector is divided by the magnitude, again what you will get? You will get the unit vectors. Okay, so unit vectors are very important to show the directions and to tell something about the vector. It is not possible always to define the actual vector. Okay, if you want the direction to Bangalore, you can say it is 100 some 500 km in this direction. Okay, so this may be going to your unit vector. Okay, from here on you have to show. You cannot go to Bangalore and say this is the 500 km Bangalore in this direction. No, it is not possible. So the smallest unit which we can use in your measurement, that is also sometimes becomes the unit vector. Okay, so remember, unit vector is the vector whose magnitude is unit. Suppose you are having a vector A over here, say of a smaller length. So suppose vector A is here. Okay, suppose if this vector, if I multiply by a number, if vector A is multiplied by a number, say how much you want, you can take it as 2. If this vector, if I multiply by 2, what will happen? What will be the new vector? Can you say 2a, or what will happen to the actual diagram of this one? It's very simple. Since 2 is what? 2 is a number. It don't have any direction or something, so no need to think about much. It is nothing but a scalar. Okay, so just you have to multiply. So a will become what? 2a. Suppose it is a is say some 2 meter per second. So multiply with 2, it will become what? 4 meter per second, like that. Okay, so a will become what? A will become 2a. A will become 2a. So then what will happen to the diagram? So diagram will become simply 2 times the original length. Okay, so from here to here, this is what going to be 2a. Okay, so simply just you have to increase its magnitude. Direction will not change. Direction will be as it is. Then you may ask, suppose if I multiply by, suppose you are having the vector A here. Suppose if A is multiply by -2, what will happen? So very simple. If you multiply by -2, so this will become what? -2a. So a will become what? -2a. Minus a is what? Minus a is negative of a. We know that a equals to minus a cap. So negative of vector a is what? Minus a cap. Okay, so we can write like this. So negative minus a is what I can write is minus a is negative of vector a. Minus a is negative of vector a. That means what? Negative of vector is a vector whose direction is opposite to the original direction. Okay. So what we have to do is, so when you multiply vector a, which is in this direction, with a -2, so what will happen? You will get the vector whose length is 2 times the original vector, but in opposite direction. So this is what going to be 2a. So this is what -2a. Okay. So it is nothing but just a simple multiplication. Okay. Then in general, if I take multiply. If I multiply vector a, so this is vector a. So if vector a is multiplied by some number n, okay, some number n, then resultant is what? Then resultant is what you can say? Resultant is given by n into a. This you have to remember. Okay, so resultant is given by n into a. So resultant, it is celebrated as r. So vector r will be n into a. So n is what? N is here. It is nothing but a scalar quantity. It is nothing but a scalar quantity. Simply you can say scalar. Okay. So if it is n times, so resultant will be what? So it is going to be, we don't know what is the n. It may be 1 or 2 or 3, whatever. So this will become what? N into vector a. Okay. So this is what we call it as multiplication of vector by a scale. Okay. So what we call it as multiplication of a vector. Multiplication of a vector. Multiplication of vector by scale. Okay. Whenever you multiply any vector with a scalar may be a 10 or 20, means it is a number, or it may be the mass, or it may be the time. These all are what? These all the scalars. Okay. When you multiply that scalar vector with a scalar quantity, you will get the vector which is that scalar times the magnitude. Okay. So if I want to write some sentence over here, so if a vector is multiplied, multiplied by a scalar, if a vector is multiplied by a scalar n, then it gives vector, then it gives a resultant vector which is n times the given vector. Okay. So very simple. So if a vector is multiplied by scalar n, then it gives a resultant vector which is n times the original vector, or n times the given vector. If a is given, if you multiply by n, so it will give the n into a. So that is what. N may be negative also. If it is multiplied by minus 2a, so what will happen? Direction will get changed. Okay. So what finally we'll get? We'll get n into a. Okay. That is what the multiplication of a vector by scalar. Then you may ask, what will happen if I divide it? Suppose you are having a vector a here. If a is divided by 2, so what will happen? This will become vector a by 2, because it is scalar. So normal division you can do, normal algebra. So a by 2 means what? It will become half of this one. Okay. So vector a by 2 will become like this. Or if you divide by minus 2, or generally if I write here, generally I will write, if a is divided by n, if a is divided by n, or you can call it as scalar n, then resultant is, so how we can write? Resultant is equals to vector a divided by n. Okay. So this you have to remember. Okay. So when a vector a is multiplied by n, it will become n into a. When a vector is divided by n, it will be a by n. Okay. Then you may ask you very simple thing, why? What is the need of this one? Here need of this one is, this is possible when n is a scalar. Okay. So if you multiply any scalar quantity with a vector, no problem, you can go with the normal algebra. But if multiplying quantity is also vector, then problem creates. Then you have to go with the rules of the vectors. Okay. So for this, for multiplication and division of vector, no need to follow the any vector rules. It is just a normal algebra. Just you have to multiply. Okay. So resultant is always it depends on the scalar sign also. Okay, whether it is positive or negative. So next we'll go vector operations. Okay. Vector operations. Vector operations doesn't mean that we have to operate some vector. So Vector operations means what are the mathematical operations possible with a vector. So one, it may be addition and subtraction. They are almost similar. Okay, addition and subtraction. So another is multiplication of vector. Okay, so these two operations are possible in case of vectors. So division is not possible. We cannot divide a vector with another vector. Okay, so that is what the note you have to take. So within this, so I will go with the what addition of vectors. So if we take the addition of vectors, so it's very simple. If vectors are like this, so one vector is here, so another vector is here. Okay, simply you can this is vector A and this is vector B. Simply just you can take this its tail. So these two are separate vectors in the same direction. So take just its tail and connect it here. So its head will come here. So this will become what resultant. So that is what A plus B. Okay. So this is what vector A plus vector B. Okay. So suppose they are in opposite direction. So what will happen? So one will become negative. So what will happen? You will get the subtraction. Okay. So if one is on this direction, if another is on this direction, so resultant will become what? Resultant will become some A minus of B. But if the vectors are like this, so if the vectors are, one vector is given like this and another vector is given like this, if they ask you to add these two vectors, so what will be the answer? Or suppose one vector is given like this and another vector is given like this, so if they are asking to add these two, so how we can do that? Or some vector is given here and another vector is given in this direction, so what will be the result? Okay, so there are the methods to add or subtract the vectors. So usually we use two laws. So laws of vector addition, So one is triangle law of vector addition. Another is parallelogram law of vector addition. Okay, so vector addition. So these two we usually follow. One is the triangle law of vector addition, another is parallelogram law of vector addition. Okay, so polynomial law of vector addition will also come, so that we can discuss while discussing triangle law only. So that is what when there are more than two vectors are there, then we can go with the polynomial law of vector addition. Okay, that we'll see when it will come. But mainly what they ask in your exams or board exams is laws of vector addition, means you have to go with the triangle law of vector addition or parallelogram law of vector addition. Okay, so same things we have to follow it. We have to follow with the subtraction of the vectors also. Okay, so we'll go with the one by one. So that is, first one will go with the addition of vectors. The examples. So addition of vectors. Okay, so suppose I am having one vector over here. Okay, say this is vector A. I want to add this vector with another vector which is in this direction. I call this as vector B. They are asking what is the result. If we add these two, what will be the resultant? Okay, so very simple. The first step is draw the first vector in the given direction as it is. Okay, so I will draw the first vector here in the given direction with the same length, whatever length they are given. Okay, then take next vector and in the same direction. You are not supposed to change the direction. Okay, so take the next vector or draw the next vector or vector B such that its tail should coincide with head of the first vector. Its tail should coincide with head of the first vector. Okay, so I will take this vector and put it here. So what will happen? This is going to be what your vector B. This is what your vector A. So length Okay, now this is correct. So vector A and this is vector B. Okay. So vector A you drawn as it is with a given length and direction. Next, draw the vector B such that its tail coincide with head of the first vector. Now, look at their directions. They are in what? They are in the same order. They are in the same order. Same order means same direction. Okay. Try to understand properly. Based on this, we are going to construct the definition of first law, that is triangle law. Okay. So what is that? First we have drawn the given vector as it is. Then second, draw the vector B such that its tail coincide with vector A. Now their directions are same. Directions they call it as what? Order. So these two are in same order. Okay. Now if we join these two, this will become what? Triangle. Okay. So let us join. Let us join these two. Okay. Now when you join these two, then question arises, what is the direction of this one? Okay, this is in this direction, this is in this direction, and so if you go like this, it will become here, but you should not take that direction, you have to change the order. So resultant will be what? In this direction. This is what the resultant. Okay, so now these two are in same order, but third one will become what? That is what? Opposite order. So this is what the resultant. This is what the resultant. Resultant vector, that is vector A plus vector B. Okay. So what you have done? You have taken two vectors as the sides of two adjacent sides of a triangle in the same order. Okay. Now the third side of triangle. This is what? This is going to become triangle. So third side will become what? Third side will become the resultant, but taken in opposite order. Same direction should come here, but it is not coming there. It is going in opposite. Okay. So we have to take in opposite order. So this is going to be what? This is going to be your what? The answer. Okay. Suppose you are having one vector is here. So suppose you are having one vector in this direction plus another vector say in this direction. Okay. So what will be the resultant? Just draw as it is. So first vector, draw as it is. Draw the given vector. Draw the first vector with given length and direction. Okay. So next step, draw the second vector such a way that its tail coincide with head of the first vector. Head of the first vector. Okay. So now these two are in what? These two are in same order, same direction. So resultant is going to be here. Okay. So if you take the same direction, so this is what going to be resultant. So now if you take this is here direction and this one is here, so direction should come here, but we are not going to take same direction, so we have to take opposite direction. So this is what going to be your resultant, that is vector A plus vector B. Okay, getting what we are doing. So here also what? Here also you have to concentrate on the direction. Okay. So if you want, I will write the steps also. Okay. So what are the steps? So steps is first one, draw first vector with given magnitude and direction, with given magnitude and direction. Okay, second step. What will be the second step? So second step will be draw the second vector. Draw second vector such that its tail should join. Its tail should join, or it start from the, simply you can write it start from the head of the first vector. Okay. So its tail should start, or its tail join with head of first vector. Okay, head of first vector. Okay. So draw the second vector such that its tail join with join to the head of the join to the or start to the starting from the head of the first vector. Okay. So what is the third step now? What is the third step? Now these two will become the two sides of triangle. Now you join tail of the first vector to the head of the second vector. Okay. So now join tail of first vector with head of second vector. Okay. So that will give the resultant. Okay. So this gives the resultant. This gives resultant taken in what? Taken in opposite order. Taken in opposite order. This is very, very important. Okay. So taken in opposite order is very, very important. Okay. So these are your simple steps, not required to write steps or something, but just to remember, to make it easy, I am simply writing the steps. Okay. Now we can define the triangle of addition. Okay. This is what triangle of addition. When you take these two sides, so this will give you a partial triangle. When you join the third side, so this will become what? This is a triangle. So how we can define it? If two non-zero vectors are taken as the sides of a triangle in same order, then resultant will be third side of a triangle taken in opposite order. That's all. When two non-zero vectors taken as the sides of a triangle in the same order, then resultant will be the third side of a triangle taken in opposite order. So order we should mention. Okay. So let me write that one. What is the triangle of addition? Very important. So shall I write here or let me write here? Okay. So if two non-zero vectors, let us write it here. Okay. So if two non-zero vectors are taken as the sides of a triangle, sides of a triangle in same order, then resultant is third side of the triangle, taken in opposite order. Okay. Taken in opposite order. Okay. So this is what the definition of triangle of addition. Okay. Triangle of addition. Okay. So this is what the definition. Okay. So this is what going to be a definition. Remember that one. If two non-zero vectors are taken as sides of a triangle in same order, then resultant is third side of the triangle taken in opposite order. Okay. So remember the definition. Most of the time they will ask you state and explain triangle of addition. If they ask state and explain triangle of addition, write this definition, then Then give any one example. Then if you want, you can write these steps. Okay, you have to come in opposite order. Okay, first write the definition, then give the example, then write the steps. Okay, so this is what triangle law of vector addition. This is what triangle law of vector addition. Okay, so starting from there, from the definition, you can come with the example, then you can write these steps. Okay, so most of the time they will ask in the theory, state and explain the triangle law of addition. Okay, so this is what triangle law of addition. Just we have discussed the definition today. We have to go with the many examples in addition when the many number of factors are given. So many things are there. So as of now, time is over. So we'll discuss more about the addition in our next class. Okay. So take care. Bye.